Okay, recording in progress. So I hope this will work. No. Yeah, I hope this should work. I can change the screen. Yeah, there. Okay. So I think the meeting is going on with this, and yeah, the recording is going on. So the true problems here is, I think the lower one will start with. Trace the output of NAND gate if the two inputs A and B are as shown in the figure below. So this is our problem. Now what I'm going to do is, let me just exit this again, this screen, and then anyway, whatever maybe the input is, this is just an example. So trace the output of NAND gate. So first of all, what you need to know is uh, the NAND gate. Uh, this is NAND gate, not AND. So you have a two input NAND gate. You have input A, input B, input. This is the output. So you have to see the truth table here. So the truth table of NAND gate is like this. 0 0. If you are having 0 0 input, so AND gate will result in 0, and then there is a NOT gate, so the output will be 1. And 0 1, in 0 1 also AND gate output is 0, so with the NOT here output will be 1. So 1 0 also output will be 1. 1 1 also, when the two inputs A and B are 1 1, then AND gate output, say if you look at this, NAND gate is just a combination of AND gate and NOT gate like this. So if you have 1 1 here, the output of AND gate is 1, and there is a NOT here, means the output will be 0. So the output will be 0. So this is the condition we have. So when either of the input A and B are 0, the output will always be 1. When both the input are 1, the output will be 0. So that is the case. Now in this particular problem, so let's look at this. So I think I can just trace it a little bit like this. Just a minute. Not like that. Exit. Keep. Just 1 minute. Just hold on. I have to go to Paint. So I'm making Paint. I'm opening Paint file for now. Open, download. So what I need to do is I need to crop the waveform so that I will only have that waveform, and I will be able to just hold on. So this is crop. Okay, so I'll take this picture with me, then I'll put here. Oh no, not like that. Where is Paint? Copy visible layer. Now if I can paste here. Nah, doesn't work like that, so I have to save it. Save as JPEG. None. This is a trial and error, so I hope this works. Go to this. None. All right, I think I got it right. So I think the screen is still visible. So this is the thing. And like I said before, here, if by looking at the truth table, if any of the input A and B are 0, the output is 1. If both the inputs are 1, the output is 0. So we'll trace it like this. Now let me draw a dotted line, vertical dotted line, a vertical line here, vertical line here. And let me draw another dotted vertical line here. With your free hand, you can draw better, even better. And out here also, you can see that there is a dotted line. So for every step where the input changes, I'm drawing a vertical line. The input, either the input A or the input B value changes, then I'm drawing a vertical line. So here also the input B is changing. So at every places where you find that the input, any of the input A or B varying, then you have to draw the vertical line here also. Here you see that the input A is dropping from 1 to 0. So let me draw a vertical line here. It's quite tedious with me because I'm doing on the spot here, drawing on a, this thing is difficult. Anyway, up to this I will do, the remaining you will have to continue. So what you need to do is that, between this interval, between this interval, this arrow, you find that A value logic input is 1, B logic input is also 1. So when both the logic inputs are 1, the output should be 0. If you remember, here between this interval, like the first interval here, both A is 0, B is 0. If both of them are 0, that means the output is 1 according to NAND gate truth table 1. So this is, let's say, 1. Now between the next interval here, A is 1, B is 1, so the output will drop down to 0. So this is 0 level. Now the next interval here is this, between this and this. Here you see that B is 0, A is 1. So if one of the input is 0, the output of NAND gate is 1. The output of NAND gate is 1 again. Now in this next interval here, you find that A is 0 here, B is also 0. Then both of them are 0 means the output is 1. And the next interval here, B is 0, A is 1. If one of them is 1, if one of them is 0, it is still 1. Here, B is 1, A is 1. So in this interval here, both A input and B input are 1. So if they are both 1, the output will go down to 0. So here A is 0, B is 1. So in this interval, you will find that one of the input is 0 means it will go to high. So 0, 0, it is still high. Like that, I think you can continue. So here in this case, the next interval here, this is 1, this is 1. If you look at the arrow here, between this, 1, 1 means in this interval, if both the inputs are 1, you remember according to the truth table of NAND gate, the output will go to 0. And here in the next interval, A is 0, B is 1. If one of them is 0, the output will go to 1. And you can understand the drawing I make here. So in the last interval here, B is 0, A is 1. If one of the input is 0, the output is always 1. So this is the output. So your logic output is, this is the 0 level, This is the one level. This is your output. Okay, this is your output. So you will determine the output waveform depending on the truth table only. You have to look at the NAND gate truth table and identify the NAND gate truth table, and from there only see wherever the NAND gate if one of the inputs of this NAND gate is zero, the output is always one. Only when both the inputs are one, the output is zero. So this is exactly what happens. So at every step in the input waveform, wherever there is a change in the input, like for example, B is going from 0 to 1, A is going from 0 to 1. At that particular point, you have to trace the dotted line like this below. And here you will find that B drops from 1 to 0. You have to trace the dotted line. So you can see that here between this interval, A value is 1, B value is 1. In that case, only the output is 0. When in a certain interval, when both the inputs are 0 or one of the inputs are 0, then the output is always 1 according to this truth table. So you have to understand according to this truth table only. Let's stop for now.